In this last video for chapter 27, which I promise is the last video, we're going to talk about genetic sex and then phenotypic sex. So genetic sex is discussing what the chromosomes look like. So this is your sex based on if you have two X chromosomes or if you have one X and one Y chromosome. This is determined at fertilization. So you are either male or female depending on the chromosomes that you have. If you are XX, then you are genetically a female. If you are XY, you are genetically a male. Phenotypic sex, on the other hand, is what you look like. So this refers to an individual's internal and external genitalia. So if you have ovaries and female genitalia, then you're typically seen as phenotypically a female. If you have testes and male genitalia, then you are generally identified as a phenotypic male. And this can usually be determined by around week 20, but this won't become apparent until after week 7, because that's when the chromosomes on the Y chromosome, the gene on the Y chromosome that produces testosterone gets activated, which we'll talk about in a little bit. Now, genotypic sex and phenotypic sex don't always match. So there are disorders, and actually this is linked to a video that you can watch, and I'll talk about that in a minute. Genotypic sex, you can be an XX, but you can have structures that make you look like you are XY. And so here's an example of an infant that has congenital adrenal hyperplasia. So in this case, the infant's adrenal glands produced a lot of testosterone. And when they did, the labia major fused, so that's what you're seeing here. So it looks like a scrotal sac, and the clitoral head here enlarged to look like a small penis. So this can actually cause problems if people aren't sure if their child is phenotypically or is genotypically male or female. Another disorder is complete androgen insensitivity syndrome. And so here is an individual that has this disorder. So when you look at her, she looks very much like a female. She has all the female structures externally, but she doesn't have ovaries. She doesn't have a uterus. She's actually a male. Her testes are have never descended, so they're in the pelvic cavity still, and they never produce, or they produce testosterone, but because she is insensitive to the testosterone, a process called aromatization occurs where the testosterone is converted to estrogens, which produces all the phenotypic, the female phenotypic structures that we see. And so individuals that have complete androgen insensitivity genotypically have an X and a Y chromosome, but phenotypically look very much female. And this disorder oftentimes doesn't get identified until much later, sometimes as late as when they are supposed to be going through puberty and they don't have their first menstrual cycle. That's what triggers medical testing. And again, video here. And actually this video is going to be this female here talking about her complete androgen insensitivity syndrome. So sex determining regions. So I told you that sex determination occurs at birth or at fertilization, but it doesn't start being expressed until about week 7, and you won't be able to identify it until closer to week 20 or 24. So the sex determining region on the Y chromosome contains a gene. The gene is the SRY gene. And if you have a Y chromosome, then at around week 7, that gene gets activated and it produces testosterone. Females do not have the Y chromosome, so females do not have or will never produce the testosterone at week 7, and so females have the female duct system form. But for males, at week 7, when testosterone is secreted from the SRY gene, that the mesenteric ducts start to form, and the paramesenteric ducts are going to degenerate. In females, because no testosterone is produced, mesenteric ducts degenerate and the paramesenteric ducts will form. So here you can see these, like, I don't know, lighter pink or purple are the mesenteric ducts, and then next to the mesenteric ducts are the paramesenteric ducts. All embryos have both. One of the ducts will degenerate when, or depending on if testosterone is released or not. This is from my anatomy and physiology textbook from McKinley, my older one. I could not find a good picture in ours. I did find it later, but I already had this made, so I'm just going to use this one for now, okay? So the gene that stimulates the mesenteric duct formation is known as the SRY gene on the Y chromosome. It is activated right around week 7, and that's the only time it becomes active, and it produces a huge surge in testosterone, which causes the mesenteric ducts to form. If that testosterone doesn't get produced, then the paramesenteric ducts will form. And so this is the picture. This is just from the McKinley Anatomy and Physiology. You can see the homologous structures forming and how they look as well. I think this is it. I'm done with this chapter. So I hope you enjoyed the reproductive system. Chapter 28 will be coming shortly. Bye.